Hello students, we are now discussing question number 95 of KVPY SX paper of 2021. This is fifth question of part 2 of physics. Let's see what the question says. It's a good question actually, I like it really. So the question says that from a carbon nanotube of 1 micrometer length, 1 nanometer radius, 10 electrons have been removed. Now just notice the values guys. uh, if I draw a cylinder, okay, of length which is equals to 10 raised to power minus 6 meter, and it has got a radius of 10 raised to power minus 9 meter. Okay, then just have a look at the difference in the order. Like the radius, the length is 1,000 times of the radius, so we can treat it as a thin wire. We can treat it as a thin wire. R is much smaller than L. Okay, so this can be treated as a thin wire, and we can treat it as an infinite wire. In fact, 10 electrons have been removed. So the lambda for this wire will be given by charge upon the length. So that will become the lambda for this wire. Now, what will happen? We want to move electron in a circular orbit around this wire. So let's talk about the electric field due to an infinite wire having linear charge density lambda. The electric field due to this wire at a distance r is 2k lambda by r. Now this multiplied by the charge on the electron becomes the force, and because of this force the electron is able to move on a circle, so this must be equal to mv square by r. And from here we notice that r gets cancelled, so basically mv square becomes equals to 2k lambda e, or in other words mv square by 2 becomes equals to k lambda by e. So the kinetic energy has got a fixed value of k lambda e. That means even if the electron is moving in different orbits, okay, then also the kinetic energy is going to remain the same. Now, from where comes the question of orbit, or how do we identify the second orbit? If this is the first orbit, how do we identify the second orbit? Well, we use the condition of quantization of angular momentum. So we are going to write mvr is equals to nh by 2 pi. That is still valid. Okay, so kinetic energy is fixed. MVR is equals to NH by 2 pi. As we change the value of N, the value of R will change because V is fixed. V is fixed. So we can say that R is proportional to N. Other quantities are fixed. So as the radius, as the orbit number is increasing, the radius will also increase. Okay, now the question talks about that the energy of electron moving in a stable is calculated by applying Bohr model according to the frequency of the radiation required to excite electron from its ground state to the next excited level. So let's talk about this now. So if I talk about energy of nth state, I will be writing the kinetic energy plus the potential energy. Now this has got a fixed value. Let me write it as k naught. And potential energy. So potential energy will be see, do we have a measure, a way of writing potential due to an infinite wire? Well, no, but we can still write the potential difference. So right now I'm writing it as potential energy in the nth orbit, but if I have to take the difference of second orbit and first orbit, then k naught will get cancelled and I'll end up writing potential energy in the second orbit minus potential energy in the first orbit, which is essentially like the charge on the electron into like V2. V2 will become potential, value of potential in the second orbit minus value of potential in the first orbit. So this will be how much? Like how do we write potential difference due to an infinite wire? If we write it as 2k lambda ln, then R2 by R1. We write it as R2 by R1. So this much becomes the energy difference between the second orbit and the first orbit. Okay, uh, yeah, actually it's R1 by R2. So basically to get rid of the minus sign, we can write it as 2k lambda E ln R1 by R2. Okay, and if we are talking about the first orbit and the second orbit, then this ratio will become equal to 2. Okay, let's just take the mod here, guys. I think R1, R2 is bothering me. So let's just take the mod here because we know that we are interested in calculating the magnitude. So the energy that will be liberated because of the transition, that energy can be written as 2k lambda E, 2k lambda E, and then ln 2. Okay, and lambda will be how much? It will be 10 times of electron divided by L. Okay, so this much energy will be released. Now, if this energy gets converted into a photon, then the frequency of that photon can be written as nu. And to get the value of nu, we will equate this entire quantity with h nu. So the value of nu will be 2 into k. I am now starting to substitute the values. So k will be 9 into 10 raised to power 9, and then we have a 10 here, then we have e square, so 1.6 into 10 raised to power minus 19 square of this, and then ln2 is 0.693, so let's keep it as 0.7 divided by L. How much was L? How much was L? It was 1 micrometer. So 10 raised to power minus 6. And then we have this H also. So this was 6.6 into 10 raised to power minus 34. So this is how we can judge the frequency and how much are we getting. So this will be like, if I adjust the powers of 10, so we have 10 raised to power minus 38, 10 raised to power minus 38 divided by 10 raised to power minus 34, so that will be 10 raised to power minus 4. Then adjusting this, we get the value as 10 raised to power 5. Adjusting this, we get 10 raised to power 11, 10 raised to power 12. So 10 raised to power 12 is what we get after adjusting all the tens here. And then we have 18 into zero point 0.7. 18 into 0.7 by 6.6. So using this value, you are now in a position to judge the kind of radiation it will have. Many of the students remember the value by in terms of wavelength instead of frequency. So you can also get the value of wavelength. How? By using C by nu. So it will be 3 into 10 raised to power 8 divided by 18 into 0.7 into 6.6, and then 10 raised to power 12, right? So this becomes how much? So this becomes 10 raised to power minus 4 here, adjusting the values of 10, and then this will number will become something close to 18, like it will, in fact it will be more than 18. So something more than 18 divided by 18 is 1 point something divided by 0.7, so that's again 1 point something something into 10 raised to power 4, somewhere close to that. So what we are looking at right now is, if I talk in terms of nanometer, so we are probably looking at like this will become few hundreds of micrometer. Okay, so if I now look at the range, so visible is, it's not visible, it's not ultraviolet, it's not X-ray, so it has got to be infrared, because visible has got wavelength in range of nanometer. Ultraviolet is still smaller and X-ray is still smaller. So this much is, this wavelength is certainly not in the range of nanometer. It is more than that. So it must be an infrared. So for this particular question, option A is going to be the answer. So I hope you understood the solution, guys. I hope you liked it. Do inquire about Vedanta Cafe if you are not aware already, and do scan this QR code to join a batch relevant to you if you want to study from Cafe teachers. All the best, students. I hope you like the solution, and I'll come with the solution of next video. Bye bye.